everyone, I'm Trisha Becker, Developer Relations Lead at Niantic, and in this video series we're covering everything you need to know to get started with Niantic's Lightship ARDK. In this guide, we'll cover communication between host and peer devices on shared AR experiences. Sharing is all about creating real-world, multi-user experiences that enable users to connect, play, and interact together with virtual objects in real places and in real time. In this demo, we'll be placing a car on our scene and enabling our users to drive it using the devices connected to our AR session in order to understand just how communication between peers works. Once again, we'll be using our low-level communication APIs. Keep in mind that we'll start with some basics that we've already covered in our previous guides. So if this is your first time working with Lightship ARDK, please check out our basics video guide to learn about the requirements and steps to set up your first project. You can also check our previous shared AR tutorial to learn the basic structure for shared AR projects. Now let's get started. We'll start by removing the main camera from the scene and adding the AR Networking Scene Manager prefab, which already contains all of the scripts and AR camera that we need. Now we'll select our AR Networking Scene Manager and on the Inspector panel, set the session identifier to host peers test. Remember to use a prefix to make your identifier unique. And just like that, we have our basic structure ready. Now we'll focus on creating the logic and objects that will interact within the space. Since this tutorial will showcase how to create a shared AR experience in which host and peer devices can communicate with each other, we'll use the plane tracker again. First, let's add an empty object into our scene. Let's call this AR Game. Now let's add the AR Plane Manager script from the ARDK package and set the plane prefab property with the plane prefab from the ARDK library. Remember to set detected planes types to horizontal. Now we're going to carry on creating some code all on our own. Keep in mind that shared AR experiences do require C# coding skills, so it's recommended to have some programming and Unity experience before diving in. If you're not very familiar with Unity, you can check out Unity Learning Area, which has tutorials of different levels and focus areas. Also, in this guide, we're going through an advanced low-level API implementation of the multi-peer networking. So if this is your first time working with our shared AR features, or you just want to go over insights and overall recommendations to get started with shared AR, remember you can check out our first guide. Okay, going back to creating our own code. Let's start by adding a new script component, which we're going to call AR Game Logic. And just like we did in the previous tutorial, we're going to create a series of variables to access our manager, our camera, and prefab. Once you've created these, we're going to define them in the Properties panel. Remember, the AR camera is a child of AR Networking Scene Manager prefab. For this tutorial, we'll use our car prefab, which contains a script that animates the car through the detected planes. If you set the destination of the car to a point in the plane, the car will turn around and drive to that point. The code's quite simple. Only about 20 lines of code will get the job done. We have two methods, one to place the car in space and one that sets the new destination. Our car needs to get to places. To get the animation running, we have an ongoing logic on the update method that moves the car to the current destination target. Let's start by subscribing to the connected event on the networking manager. This event will let us know when we're connected to the networking server. We're going to create an on-network initialized method and add it to the networking manager. Due to how objects are created in Unity, we need to add a small delay to be able to access the networking session manager. In this case, we'll use 1/10 of a second delay using wait for seconds. Don't forget to import niantic.ardk.networking.multipeer networking event args, as well as niantic.ardk.extensions. You got that right. I said niantic.ardk.networking.multipeer networking event args. Now let's continue by adding our touch events. First, we'll use the platform agnostic input under niantic.ardk.utilities namespace to get the touch event and touch position relative to the user's screen. And with that screen position value, we use the current frame hit test method from the error session to get the collision point on the detected planes. Remember to import the namespace niantic.ardk.ar.hittest. Now in this guide, we'll have a different communication approach than the one we used in our previous one. Instead of broadcasting the message to everyone, we'll send the updated position to the host, and then the host will decide how to deliver this message to everyone. On networking projects, it's most useful to have a single source of truth, a host that handles all of the logic and information, preventing data override and unsyncing. So we'll start by adding a game object variable called me. This will represent our own car in the experience. Once we get a position on this space, we'll create a new car on the scene, and if I already have a car representing me, we'll set the new point as a destination. The createCar method takes a position and instantiates our car prefab on that position. Now we're ready to start sending the data. As we went over earlier in this guide, we'll be sending data to the host, but there's also a chance that we'll be the current host in our shared AR experience. Therefore, we need to figure out if we're the current host of this session or not. We can compare the current networking host identifier with our own identifier. For this, we'll create a method called AmIHost that compares both identifiers returning true when they're the same. Now we're ready to send out our first message. So let's start by sending the position to the host if we're not already the host ourselves. For that end, we create a send-to-host method that takes a position. We'll use the sendDataToPeer method from the networking class. This method allows us to specify the receiver of the message, sending the information to a single peer. In this case, we'll set the peer as the networking host. Remember that we need to serialize the data to be sent as a byte data and that it requires us to import system.io and niantic.ardk.utilities.binary serialization namespaces. Now, to differentiate between messages, the low-level API uses tags, a numeric value that can be used to accomplish this task. So we're going to create two constants that represent the type of messages we'll handle in this experience: position_EVT and update_EVT. Now that we have our message ready with its corresponding tag and data, we need to subscribe to our networking manager to receive the messages. It's time to receive the information, so we're going to subscribe to the networking so that it notifies us when a message arrives. This method acts as a gateway for all inbound communication. Now, inside the on-network initialize that we created at the beginning, we're now going to add a subscription to the peer data received method. Within the on-peer data received, we must use args.tag to identify which type of message we're receiving. We'll use a switch statement in order to differentiate between the data received. Since the message was only sent to the host, this code will run only on the host user, no matter how it was sent. We need to deserialize the data to have the position sent, ready to be used. So let's start by creating a dictionary for all of the users on the current session. The host and the peers will have this dictionary where they store the current user list and the corresponding game object. We're going to create a variable called players where we store the game object under each user identifier GUID. This will allow us to send the GUID to other peers with a position and have them update the game state on their own. So going back to the onPeerDataReceived event, we'll need to use the position and then link it to the current sender. The peer data received args has several properties. One of them is peer, which represents the sender of the message. By accessing the args.peer.identifier, we can get the GUID of the sender. Let's create a method called updatePlayerPosition that receives the identifier and position to add a new player to the scene. We'll call it updatePlayerPosition because it will check if the user already exists in the scene, creating a new one or updating its position depending on the result. Using the identifier, we can check if the players list already has a defined player with that key and then update its position or create a new one, adding it to the players list. Now, if we run this code, we'll have a working project, but with a caveat. Only the host is receiving messages. All other players will see their own car, but not the rest of the players. Now we have our host ready to send the game state to everyone connected to the session. The only thing that's missing is to create a method to send the messages to everyone. So let's add a method called sendUpdateToOthers, where we'll send the message to a selected group of peers. We want to send the message to all peers on this session, excluding the host and the current peer that sent the initial message. We need to send two properties, sender and position. Now, since we're sending two values on a single message, we need to serialize the data in chunks. We use the binary serializer to accomplish this task. So each data is serialized in order, and we need to remember the order and data type in which we serialize the information to be able to correctly deserialize the information afterwards. After having the information serialized, we need to create our list of peers that will receive the message. The multi-peer networking class has a property called Other Peers that lists the peers on the session, excluding the current user. Once we convert it to a list, we could remove users from it to filter the reach of the message. In this case, we'll remove the sender as well as the host. In fact, the host is already excluded since it's the one calling the Other Peers property. But let's do this for the sake of learning. Okay, finally, we're ready to send the message to everyone. In this case, we use the method sendDataToPeers in plural and set the peers property with our own list. As this is a different message, we've changed the tag to update_EVT to be able to react differently to it. On the on-peer data received, we'll add a new case under the switch clause. In this case, we detected that our tag is update_EVT, so we can have a different logic to process the message. Since we're sending two properties inside the data, we also need to deserialize it. We'll get the sender ID as a system.guid and the position as a vector3. When we deserialize the data, we need to do it in the same order as the serialization and also cast the values accordingly. For the purpose of this tutorial, we'll use the same method as before, updatePlayerPosition. This method will create a new instance for each player and then update its position. That's it. We're done, folks. Now you can successfully create your own version of a shared AR experience that enables users to send messages to different peers and send several variables in a single message. You can test out what you built on Unity's mockup scene and also on your devices. Remember, if you need guidance, check out our Virtual Studio video or documentation at our website. So what now? Check out our tutorials page for several tutorials on specific Lightship topics. Then join the Lightship community Discord and discuss Lightship projects with other developers. And finally, make sure to follow Lightship on Twitter and Instagram to see projects built with Lightship and stay in the know with updates to the platform. Happy building!